Hi, welcome everyone. In today's video, we are going to learn how to estimate a FGLS feasible generalized least square model in STATA and why it is been necessary, why we are not using fixed or random effect model. We are showing that. So there is a sample data which is already loaded in this data file. So I will run the random effect model, that is XTReg, ROA, ln size, ln risk, ln ESG, FE. So this is my fixed effect model, and in that I will use one heteroskedasticity test command. For that I have some commands available. The command name is xtest3 or this one. So I will try to do both. So this is xtest3. So it says that there is heteroskedasticity. There is another test this is made by somebody else. So ROA, ln risk, ln ESG, ln size, ID for identification, ID for time. So I have a time variable here. So before running fixed effect model, you have to identify and tell STATA that it is a time series, it's a panel data. So here we can see that it is showing that there is heteroskedasticity. So even if we are using fixed effect model which is trying to solve that cross-sectional heteroskedasticity in the data by adding cross-sectional identifier, but still your model can have heteroskedasticity because of slope heteroskedasticity which is changing across cross-section, or time series heteroskedasticity, and so if it is only because of slope, we can run a model called XTRC. So the command is called XTRC, which is random coefficient model. ROA, ln RASK, ln ESG, ln size. So when I run this, we have to identify it as external data, ID, time, and page up. So this command, it will estimate a model for slope. In this model, rather than only intercept changing across cross-section, here slopes are also changing across cross-section. This test is confirming that slopes are not constant across cross-section. So this model can be used. So you can look for more details. So help XTRC. So when I go here, so here you can go down and see the command. So this is the command, and if you want to see all the commands, you need to write beta after comma. So I will do the page up twice and beta. When you do this, it will show you all the coefficients for all the cross sections like this. So since you can see few of the cross sections variables are significant and few there are not significant, this is the identifier that the slopes are being different across cross sections. Here you can see it is different. So this way, this is one of the way. If the heteroskedasticity is because of the slope which were assumed constant across cross section in the fixed effect model, but heteroskedasticity can also come because of the standard error being varying across cross sections, or because of time series heteroskedasticity. For that, we are going to tell you how to run the the FGLS model. So its command is XTGLS, and it's ROA, XTGLS, ROA, ln risk, ln ESG, ln size. When you run this, it gives you a FGLS cross-sectional time series FGLS regression, where the panels are assumed homoscedastic, correlation is assumed that there is no autocorrelation. But since we already know that there is heteroskedasticity and we can also check for correlation, the command is xtserial ROA ln RASK ln ESG ln size. So we run this, it's showing that there is autocorrelation. So we have to modify this FGLS model. For that, we'll do help XTGLS. Here we can see that this command can be used panels correlated when there is heteroskedasticity and correlation. So what we'll do is we'll go back to the command, comma panels CORR. Oh, so close bracket. So panels, option panels is not allowed, so it's panel. It's not allowed. So help. Oh, okay, so I'm using command on the wrong command. So it should be XTGLS. So go up, XTGLS panels CORR. So when I run this, it's saying that it will not work because I'm still using the wrong command. So page up, XTGLS, comma panels CORR and XTGLS. So it has run the XTGLS command. Here the panels are heteroskedastic with cross-sectional correlation. Okay, so we have assumed that there is correlation, and the cross-sectional correlation is actually the correlation of the residuals which are across the cross-sectional, which is also called cross-sectional dependence. So if there is cross-sectional dependence, it can be checked using XTCD command. So how we can check? We can go back to the FE model. So I can go back to FE model, then estimate, predict resid, residual, and then it's already defined, so I have to drop it first, drop resid, and then generate again. So XTCD cross-sectional dependence RESID. So it is saying that there is cross-sectional dependence, it is significant, it's not independent, so it means we can use this model. So cross-sectional autocorrelation, so this model is used. So it is assuming that there is heteroskedasticity and there is cross-sectional dependence, so it is adjusting for that problem. So one problem still left, that is autocorrelation, that is time series autocorrelation. So we'll go back to help XTGLS, and we need to see what kind of autocorrelation we can control for. We can go for core AR1. So if we assume that the autocorrelation, which is time series autocorrelation, is AR type 1, so we can go back and we can try to run it. So XTGLS when I score CORR AR1. So when I does this, it should be small letters, I think. When I run this, it is now assuming that it is heteroskedastic and cross dependence, and it has autocorrelation of time series. So this is the model which is made based upon assuming the presence of hetero, cross-sectional auto, and time series autocorrelation, and the model is adjusted to those problems so that the results are not creating any problem. So we can use this model if these problems are there. So this is the FGLS model, which is more popular as compared to the random act fixed effect model, because it can control for these three types of problems. So further, if there is any other problem like reset test, which talks about the missing specifications, it can be controlled by adding square variables one by one and check where the square variable is significant. Keep the significant one. It will solve the problem of reset test, which is the missing square specifications. Thank you very much for watching. This video was about GLS model and its ability to control the problems. Thank you.